2 places. So there's our decimal. Grab a different color here. We're gonna go left. There's 1, there's 2. That's where you put the new decimal. So this becomes 0.20.
Yeah.
Okay. So what is 45% as a decimal?
0.45.
0.45. Good. Now what about 3% as a decimal?
0.03.
Very good. So I'm going to show that just in case you want to look at it later. Move the decimal left once, twice. You fill in those missing spaces with zeros. 0.03. Now kind of in the same direction. What's 110%? You probably heard that before. You got to give 110% effort.
Yeah.
Well, let's see what that actually is as a decimal. What do you think here?
1.10.
1.10. Very good. Very good. Okay. Now back to our, well, actually we can go the other way as well. We should talk about this as well. Decimal to a percent. So let's say I tell you it's 0.35. Do you remember how to convert that to a percent if you're given a decimal?
Wouldn't it just be 35%?
Yes. So to undo division, use multiplication, you multiply by that. Yes, it is 35%. So in the adult world, adults like percentages because they don't like decimals. In the math world, you have to use decimals. Like you can't really use percentages as they are. So it's like, this is how you present your answer. This is how you manipulate numbers. How about 0.012? What would that be as a percent?
Um, well,
So when
or
you're multiplying by 100, you're moving the decimal right 2 places. 1, 2. How do you want to change your answer?
1.2%.
Yeah, and that's weird, right? It's like, wait, a percentage can be a decimal? Yeah, it can be. You'll even see problems like this where they ask you to convert this to a percent. What would this be as a percent?
0.43.
0.43%. Exactly right. Okay, so here's what you have to remember. If you're in the world of percentages and you want to go to a decimal, you divide by 100. If you want to go from a decimal to a percent, you multiply by 100. You have to be super fast at this, good at this. This is the decimal is going, you can think about how you want to move the decimal. Like when you're going from decimal to a percent, we talked about it moving to the right. Decimal left, maybe you want to remember that as well. All right, so back to our original problem, kind of a nice aside there to be able to work through this. So 20% more, and I love how you're circling, boxing and stuff. I think that's great. We cannot work with percentages directly, so we just said 20% is really 0.2. Could you multiply these numbers together for us, please?
Yeah. 2.4.
2.4. Good. Now, that means that it's the original 12 plus the 20% more, which is the 2.4. So we know it's 12 plus 2.4, which is 14.4. Whenever you're doing a percentage problem and you're going more, you can do 1 plus the percent. So what do I mean by that? Well, in your case, 1 plus 0.2 is 1.2. Okay, so if you take your original number 12 and multiply it by 1.2, can you tell me what that results in?
Wait, am I multiplying or adding?
I'm asking you to multiply these two numbers, 12 times 1.2.
14.4.
And does that look like any other numbers that we've calculated in this problem?
Um, yeah.
Yes. So there's two ways to calculate the new amount. You can either calculate the additional amount and then add it to the original, or you can know to take the 1 and add it to the decimal, multiply, and add it to the original. Does that make sense to you?
Yeah.
Okay. So, let's see here. Okay. So we're going to look at another problem here. This is actually an SAT question, believe it or not. But you're actually more than capable of doing this. So, all right. A waiter receives tips from each customer. On average, the tip is 15% of the customer's bill. At this rate, it says which of the following is closest to the tip that the waiter can expect when a customer that has a bill that is $78.20. Okay, so we need to convert this to a decimal. What is this as a decimal?
That is 0.15.
0.15, perfect. And so the tip is the original amount times 0.15. All right. Now, if you haven't multiplied decimals in a while, what you don't have to do is you actually don't need to line up the decimal. You don't need to do it this way. This is actually not the most efficient way. You want to line up the digits. So it's 78.2. Let's remove that 0.15 like that. That'll make this problem a little more efficient here. So will you multiply those together, please?
Uh, 11.73.
Uh, that doesn't look right to my eye. And I'm not saying you're wrong. It just, boy, that just doesn't look right. It is right though. Okay. Wow. All right, good. So that's the tip. And you've been to a restaurant, I'm assuming at some point in your life. I mean, who hasn't? How is the tip applied to the bill? How does that affect the bill?
Um,
Maybe you're not sure. I just
yeah, I'm not
maybe.
sure.
Okay. So when you get a bill, there's the total, and then there's that amount there, and then they say tip, and then there's like the new total. Have you seen this when maybe your parents have gone out or gone out with your grandfather?
Yeah.
Okay. So the total is 78.20. The tip is 11.73. How much are they going to charge to your card? Most of us pay with cards now. What do we do to these two numbers?
Um,
All right, still not sure. You add them together. You add them
yeah.
together. Okay. So go ahead and add those together for us, please.
89.93.
Very good. Okay. So this is the first approach where you figure out the amount of the more like we did in the last problem, and then you add it to the original. The alternative approach is to use that 1 plus. So 1 plus 15% is 1.15 because 15% is really 0.15. And then you take that 78.2 and you multiply these numbers together. Could you do that for us, please?
Yeah. 89.93.
Are you surprised by that result at all?
Not really.
So it's the same, right?
Yeah.
So, well, why would you use one or the other? Well, if you only cared about how much you're paying, you would just use this. this second approach. But if you actually needed to write a tip down, you have to put that line in the tip there. I don't think I've ever seen it where like you just put this new number down and let them figure out the tip. I think that could cause some problems in restaurants, people not being able to add and subtract. So it's kind of your choice how you approach these problems. Okay. All right. Here is a problem I'd like you to try on your own before uh, we talk about maybe get back to your sheet paper. Is a really good percentage problem. It's just like the ones we've been doing, just a different scenario. So give that a try, please. How are you doing on this one?
Uh, wait, so would the new total be 120?
How did you come up with that?
Um, I changed the 5% to a decimal,
And what is the decimal?
0.05,
Okay, good.
and then times it by 800,
Okay, what is 800 times 0.05?
40.
Okay, that's good so far.
Um, and then I um I add I added one to 0.05.
Okay, so you have to decide on the approach. That's what we've been talking about. That's where your mistake is. You're either going to use the percent, okay, as is, get the new number, get the increase in this case, and then add it to the original. So this is the approach that you're using here, this approach right here. So what is the original?
800,
Okay, so what does the 40 get added to?
800.
800. So that would be, in this problem, it would be 40 plus the 800 gives you 840. The other approach, the other approach is to multiply by 1.05. It's 1 plus the percent. So in your problem, that would be 1.05 times the original 800. There are two different approaches. Like you get to decide which one you want to use. So could you multiply these together and see if you get 840?
I got 840.
You got 840. Okay. So the difference is you decide, like you either want to calculate how much the increase actually is, or you just want the new total. You see how the one on the right doesn't really give you the increase? It just gives you the new total.
Yeah.
And sometimes you want to know that. Depends on the problem. Okay, so let's go back to the representing more juice problem. Assuming you actually need some answers here. Um, so let's do these. This won't take long. We already decided that 14.4 is the correct new amount. So Priya is correct, and Claire is wrong. Okay. And the reasoning can be really anything, but I would go back and use the multiplication that we did. The better, kind of the more complete answer though, is that the original amount represents 100%.
Yeah.
And that's why Claire is incorrect, because her original amount is 80%. So that's how I would answer that one if you need to get some of that down, is, for that. You need some time to write anything down, or can I move on here?
You can move on.
Okay, so the next question says Claire's diagram could be used. So you're like, Claire was wrong. Well, Claire could be used in the following situations, which is kind of the next part of the lesson here. We definitely would do this if we had more time. So Claire's lesson is good if 15 represents the original amount. So, and we were going backward. Okay, or forwards for that matter, but mostly backwards. Okay, so there are two types of percentage problems. There are percent increases and there are percent decreases. Okay, so the answer to this one is percent decrease problem, where this is the original amount. Okay, so maybe say an example where you're starting with 15 fluid ounces, and you want to know what a 20% decrease is. Is that okay?
Yeah.
All right. So we don't have the time to do like more decrease problems. We're going to do a couple of more increase problems, which is exactly what number one is on the next page. So let's take a look at number one. All right. One sanctuary had 180 green sea turtles come ashore to lay eggs last year. The number of turtles increased by 10%. Okay, so see how this is an increase problem? It says increase or the word more. What is the original amount? That was a question for you. What is the original amount here?
Mm.
How much did they start with?
180.
180. Okay, so the original is 180. What is the percent increase in this problem?
10%.
10%. What is that as a decimal?
Uh, 0.10.
0.10. Okay, So you have two approaches here. Remember, you can either figure out how much the actual increase is on the left, or you can figure out just the new total. Which way do you want to use?
Uh, Figure out the new total.
Okay, so you have to take 1 plus the percent and then multiply it by the original. Go ahead and give that a try, please.
Wait, so I'm confused on what I'm doing. Could you repeat it again?
Well, what did we do in the last problem? What did we do in the last problem over here?
Um, Added one to the percent.
Okay. Do you have a percent in your problem?
Yeah,
Do you have an original in your problem?
yeah.
Okay, so it's the same thing, just different numbers. What is your percent?
10.
Convert it to a decimal, so you add 0.1 to 1, multiply by the original. What's the original?
8, 180.
180. Okay, there you go. You got everything you need.
Would it be 198?
That is correct. 1.1 times 180 is 198. Very good. All right. We are all out of time for today. Great job.